You're in the water loop.
Water loop.
Welcome to Waterloop, the nonprofit news outlet exploring solutions for sustainability in water. I'm the host, Travis Loop. Odor complaints and corrosion are two of the most stubborn challenges in sewer systems, and both stem from the same source, hydrogen sulfide. Kerry Koressel of IPEX breaks down how this invisible gas eats through concrete and metal, damages infrastructure, and triggers costly repairs for utilities. He explains why these problems persist despite decades of awareness, from limited budgets to competing priorities, and how new engineering solutions are changing the game. Before starting the conversation, I want to share more about this episode's sponsor, IPEX. If you value Waterloop content, please tell the sponsors who make it possible.
Waterloop.
In a major push for sustainable sewer solutions, IPEX introduces the Vortex Flow Insert, revolutionizing odor and corrosion control in municipal systems. Installed in drop structures, the Vortex creates a supercritical flow that suppresses hydrogen sulfide release, entrains dissolved oxygen, and dissipates energy without splashing, eliminating odors, preventing corrosion, and improving sewage quality. With no moving parts or ongoing costs, it's a set it and forget it innovation that pays back in as little as 1 year compared to chemicals or filters. Trusted for its rugged design and quick installation, Vortex minimizes infrastructure damage and environmental impact, helping utilities save on maintenance and comply with regulations. Discover more at ipexna.com. Let's talk about these kind of linked issues of odor and corrosion.
Okay.
I need to be educated a little bit here. What causes these when it comes to collection systems? What's happening? What's that problem there?
So really, it all goes back to science and chemistry, because it's on the slime layer of your sewage pipe is really where this H2S, hydrogen sulfide, gets started. And it's okay when it's in solution. It's really not that harmful. It's whenever it gets to some kind of splashing event, like a drop or something, that it splashes and releases it into its gaseous form, is when it becomes odorous, dangerous, and corrosive.
Wow. Can you describe where in a collection system this might happen? Like give me a visual, if you will.
Okay, let's say you're in a manhole. You've got a pipe coming in, say a 24-inch diameter pipe, sewage coming in. It splashes down into the bottom of the manhole, and it kind of looks like the Maid of the Mist. You know, Niagara Falls, you get all that mist coming up. Well, that's H2S gas. What happens is that gas floats up into the manhole structure. It's going to metabolize with bacteria that's on the wall, and it actually metabolizes with it, and it creates sulfuric acid. Sulfuric acid is what is eating into any kind of concrete component, whether it's the manhole, the pipe going away from that structure, and that anything metal that's not stainless steel, it's going to attack that and eat that away as well. So that's the corrosive part of it.
So it could corrode the cement itself, other parts of that collection system?
Other parts. I've been to job sites before at treatment plants, and they've had metal pieces or guy wire outside of the manhole 10, 15 feet away, and you can see the metal is just rusting and corroding, and it's all because of that H2S is floating up, creating that issue with the bacteria that's in the area.
Yeah. And a lot of collection systems can be very big and vast and many miles and all these manholes, right?
Hundreds and hundreds, thousands of manholes in big systems.
So keeping tabs on all that for corrosion problems is a big challenge. So it can probably go unnoticed and really do expensive damage then.
It can go unnoticed, but it can even be noticed, and still it's a big project to have to go in and take out a manhole and replace it, or take away pipe that's there, because you've got sewage going down through there 24/7. To get rid of that, you have to bypass pump, and it's very expensive.
Wow. Obviously, I can guess why odors are a problem. It just doesn't smell good.
Yeah.
And a lot of times these can be near residential areas, or, what's that side of it.
Yeah.
Tell me more about the odors.
So usually the odors are going to be the precipice to a municipality doing something, because they're going to get phone calls. One example at Minneapolis, many years ago, which actually got started with our Vortex product, was the odors were so bad, it was in a downtown area that it elevated up to the mayor.
Wow.
And that's when things start to get done. That's when the mayor gets involved. And it's hurting businesses because people are walking by, they don't like it, so they're going to go somewhere else. So it's going to hurt the businesses.
Yeah.
But yeah, odors are, people aren't going to notice a corroding manhole down in the ground, but they are going to notice the odors, and kind of like potholes. Potholes get noticed, so they get taken care of. Same with odors.
Yeah. Any idea why in 2025 here, odors, corrosion have been around for decades and decades and decades, and why they still are a problem? Why it just kind of hasn't been universally addressed?
I think a lot of it comes down to money. It's expensive to try to take care of those problems, and sometimes municipalities either don't have the means or it may not be on their priority list. Sure. Sometimes municipalities might have consent decrees that they have to take care of I&I, infiltration, things like that first. And these other things just kind of get pushed to the back burner.
Competing priorities, limited resources, that kind of thing. Yeah.
The way of the world.
Right? Exactly. Only so much time in the day.
Right.
All right. So let's pivot to the solution side a little bit. How do you go about, at the same time, reducing odors and reducing corrosion?
Right. So there are different ways to help that. One of the products that we have is called our Vortex Flow Insert. As I told you before, you don't want flow coming in, splashing to release that H2S. With our Vortex product, that's what we're doing. We're capturing that flow. We're not allowing it to splash. The flow is always exiting submerged, so there is no splash, no release of any H2S.
Take me through this. Again, like the visual part, right? Like if you're looking at a cutaway of that collection system, show me what that looks like.
Okay. So typical collection system, you got manholes spaced usually every 300 or 400 feet, typical in a system.
Okay.
You could have a manhole where you've got a 24-inch pipe coming in, it may be dropping down 20 feet.
Wow.
And that 20 feet of splash with pipe coming through a 24, it's going to be very dangerous, very odorous. So our Vortex system, or Vortex insert, is going to go into this. That flow coming in is going to go into what we call the top form of our Vortex.
Up there at the top.
At the very top.
Okay, got it.
So that flow comes into the top form of our Vortex. We increase the velocity to get this flow to a supercritical velocity. The reason we do that is as it exits the top form and enters our drop shaft, we want it to spiral down that drop shaft. Because as it's spiraling down, it's creating a negative air column or an air drag or a slight vacuum, if you will. So anything that's coming down through that pipe, such as H2S, any other kind of odors or gases, anything that's within that structure, it's going to pull it straight down through that drop shaft. At the bottom of the drop shaft is what we call our dissipation pool. This is where all the sewage enters the drop shaft or enters the dissipation pool and exits submerged. So we're not, again, allowing it to splash, but within that dissipation pool, all the bad stuff that we're pulling down, such as the odors and the gases, we're entraining it back into the sewage. Not only that, but we're also pulling down air. We're able to entrain dissolved oxygen into the sewage. Dissolved oxygen is an H2S killer because it's going to oxidize that H2S into its really bad form, into a not as bad form to send it on its way.
So you've improved that sewage that's going downstream too.
Yeah. I always call it's an oxymoron, but it's an improved sewage when it leaves the manhole than when it entered the manhole.
Wow.
Yeah, because we're, again, not allowing it to splash. So we're not releasing that H2S. If any H2S that's in there, we are oxidizing that with that dissolved oxygen to form a better, more soluble sewage to send it on its way in a better manner.
So it's definitely like a 3-for-1 then, with stopping those odors, stopping the corrosion, and improving the water quality of that sewage.
Absolutely.
Better sewage going down the collection system.
Absolutely.
Yeah, very cool.
Yeah. Well, as you guys continue to innovate and work in this area, this is crystal ball time. I know, put some pressure on you. What might be next? What might be new? You know, technology, equipment, materials, all that stuff's always changing.
Right. So, I mean, within within our industry, as far as doing the vortex kind of stuff, I mean, there are different things. We've come up with a different product that called a vortex force aerator to be able to add even more dissolved oxygen into force main applications.
That's something utilities like. They want
sure.
that.
Yeah, absolutely. Yeah, anything that says aeration, they want. Yeah, especially if you can do it on the cheap, so to speak, because again, no moving parts, nothing mechanical. It's easy to do, cheaper to do that way. Yeah. There are other things even outside of our realm, such as manholes are getting better because they're using a composite material now that is not as susceptible to H2S and the corrosive aspects of that. So a lot of municipalities are going towards that. Interesting. To expand the lifetime of their structure. Again, it's very expensive to have to go rip a manhole out. So another example is stainless steel. We insist if somebody's installing one of our vortex systems that any kind of restraints or things that are used have to be 3/16 stainless steel. Again, it's trying to improve and make that structure last longer to save them money.
Less maintenance, less replacement, etc. Right. So it's cool seeing innovation happening. It's not just like the digital interfaces at a treatment plant or something like that, right? It's like even in manhole covers, or the materials that are down in a collection system, everything's kind of constantly like, how can we make this better?
Right.
And you guys are doing that.
We are doing that.
Kerry, thank you so much.
Travis, thank you. Appreciate it.
Thanks for listening. If you want to support Waterloop's ongoing exploration of water solutions, subscribe on YouTube, rate and review the podcast on Spotify and Apple, follow us on social media at The Waterloop, and sign up for email updates at waterloop.org.
You're in the Water Loop.